right? Okay, it's all right. Color change for my pen. All right, yeah. Today's topic, Part C, object-oriented databases, a special type of databases. Yeah. Here, mainly, I like to introduce this concept. Yeah. But in our real-world applications, this type of databases may not be useful. So I will explain. Yeah. But the concept is interesting. And later we will see, although this type of database management system not quite useful in our real applications, but there is another version related to this type are very useful. Yeah, so we will go there after we learn this concept. Yeah. C.1, database catalog. So last time I mentioned a little bit, database catalog. So remember, we stored our metadata. Remember the metadata concept. Yeah. So here, the second time we visit this concept, and I like to give you a little more information this time, second time. So what is database catalog? All right. The concept of database catalog. All right. First, it contains the metadata of database. Last time I explained a little bit, this meta, yeah, in our web, yeah, in our web technology, you may learn this meta meaning before. Yeah, in our HTML, you can see sometimes you have some meta tag. So when you see this meta, its meaning is descriptive data. Metadata means descriptive data. Okay, yeah. So let me write it again. Descriptive data. Okay. People also call it the data used to describe the data, and other data. Okay, yeah. Descriptive data or secondary data. Secondary data, all right? Yeah. So this kind of data, secondary. All right. And this data, databases, that's the primary data. Primary data, secondary data, okay? Yeah. Useful information about the data in the databases. Yeah. So what kind of useful information, right? Specifically, the definition of the databases. That's useful information, okay? Yeah. And in the definition, what kind of details you need to provide? The structure, table structure, the structure, all right? Yeah. The structure mainly we refer to table structure. Yeah. So the structure here, meaning a list of tables. Tables, yeah. So why you say that? List of tables? Because one table, there is another word for a table we call relation. Okay. Here, we are learning relational DBMS, relational database management system. So what is a relation? Relation means table. Yeah. So in the academia way to call the concept of table relation, okay? The formal name of the table, we call a relation, right? The table, that's our everyday life name table. Yeah. But the formal name, it's called a relation. Okay, yeah. So the structure also, if you install the exam software, after you create a database and you populate your database, look at the tab on the top bar, there is a structure tab. You click it, you see a list of tables. So here, so you get an idea. Typically, we use tables to describe the structure of our database. Okay. Constraints. Yeah, today I will give you some basic constraints. Okay, yeah, so we will, get there. Constraints. Yeah. Type and the storage format, data type, storage format. Yeah, all right. Accessed by DBMS. Yeah. So the metadata, that part accessed through DBMS. Now, that means you cannot bypass DBMS to access the metadata directly. You will mess up. You would mess up. Okay? Yeah. Only when you access the metadata through DBMS, then you will not cause any damage. Okay, yeah, all right. Then DBMS catalog and the database catalog are the same thing. People just call them different ways. Yeah, all right. A database about the database object. Now, after I give you the basic database catalog concept, next, that's the main concept of this part C, database objects. So let me explain. Because object-oriented, so you learned object-oriented programming, right? C++, Java, object-oriented programming. So you have that background. Here, we do things different. Object-oriented databases, that concept. Okay. Here, let me give you the background, the rationale, ideas for this type of databases. Yeah. All right. Database objects here. All right. Yeah, all right. So here, this database objects, yeah. So when we talk about objects here, before we go things deeper, so let me explain the meaning of objects here, the object meaning. The first meaning, ordinary object. Ordinary type. In our daily life, we call things objects. So this object, that object, this is the ordinary meaning. But we have some specific meaning, not the ordinary objects. Okay? Another type of objects, programming objects. In our programming language, we define objects, right? We create objects. That program, that's not ordinary programming objects. So another type. Yeah. So we have these two different meanings here for our, in our understanding. And here, this object, database, that's the, based on the context, that's the first type, ordinary object, database object. One database, all right? One database, you have a collection of data, right? That collection, we call it an object. That's the general meaning, ordinary meaning, right? Collection of data, that ordinary object. Here, it's not a programming object, right? Here, the meaning is not programming object. So we need to tell which meaning we are using based on the context. Here, based on the context, ordinary object. Yeah. So users are not allowed to modify the details directly in database object. Yeah. So you have to use the DBMS to modify the data stored inside your database object collection, collection of data, that collection. Okay, yeah. Because otherwise you may still mess up, or you may do the wrong way to damage your data, cause the damage of your data. Okay, yeah. All right. Users can only view the tables in it. Yeah. When you view, you do not change the data, right? So that's fine, that's safe. Okay, yeah. But if you need to modify it through DBMS, using the legal ways to modify the data. Okay, all right. Only DBMS can access it through DBMS. Yeah. All right. And here, another thing regarding the NoSQL systems. Yeah. In Module 1, I introduced this NoSQL DBMS. Not only SQL, we know social networking using NoSQL, this type of DBMS. The reason this type of new DBMS support fast search, instant fast search. Okay, I spent a lot of time to explain that. The traditional DBMS, in order to support keywords-based search, a lot of background work, indexing work has to be done before the content can be searched. But this type, immediately, when the data is available, fast search operations can be applied on any data item stored in the database. Okay, yeah, yeah. So that's the, but this type has a special property regarding the metadata. Do not have metadata. NoSQL systems do not have metadata. You know why? Yeah. Why? NoSQL DBMS system do not need metadata. The reason is very simple, because its structure is very simple. Yeah, I gave you the structure before. Remember, key value pairs. Okay. The structure is fixed. All data items are in this format without definition. Yeah. So that's the only data format you can use in this type of data. So no metadata is needed. You do not need extra information to describe your data, right? Already enough. Okay. That's the reason this type of DBMS support fast search, fast keyword-based search. Okay, yeah. All right. So here, that's the background information about database catalog. Okay, yeah, that should be enough. Yeah, for our background. So this information is enough. Okay, yeah. All right. Next topic now. Yeah, C.2, integrity constraints in DBMS. Yeah. Integrity constraints. You need to make sure your data follows certain integrity constraints, no contradiction. Okay, yeah, all right. Not ridiculous. All right, yeah, all right. So data integrity issue. Certain conditions on data must be applied. Yeah. So here, let's look at some basic integrity constraint types. Okay, yeah. Who will enforce them? Yeah. So because when you have some integrity constraints, someone needs to enforce the integrity, the constraints. Okay. Yeah. So basically, two parties, typically two parties, right? One party, DBMS. DBMS is one party. Another, we as users, right? Users. Okay, yeah. So let's just say the general users. Yeah. Because inside users, still we can, use several categories, different users, right? There are many different users. Yeah. But here, I do not want to get into the details for the users. Yeah. Just say the users. All right. Application programmers, yeah, so we are application programmers. Yeah. One category inside the users, right? Other than application programmers, there are other users, right? Like the business users, another type. Business users. Yeah. Those users, they do not write programs, right? Yeah. We, as application program, we write programs, but business users, they do not write programmers. They just use our programs to do the business. So business users, okay? Yeah. And system administrators, another type of user. System administrators, another type of users, right? They're not programmers. They do not write programs, right? And they are not business users, okay? They are not business users. So they maintain the system, okay? They do database operations under the instruction, typically under the instructions of business users. Okay, yeah. The business users, the administration managers, those people, they need to access certain data, but usually they do not work on the data directly. So they ask system administrators to access the data following certain requirements. Yeah, so that's the users. All right, so here, now. Another party, DBMS. Yeah, DBMS, so here we mean the system enforce these constraints automatically. DBMS, we do not need to do things manually, but we need to set it up, okay? In order to ask the DBMS to enforce the constraints. any constraint, yeah, we need to set it up. We need to tell DBMS, what do we need to do? Okay. Other than that, after that, the enforcement is automatic. Okay. Yeah. Do as much as possible. Even that, the DBMS has some limit. So here, do as much as possible. That means there is some limit here. That means many things DBMs cannot do. Okay? There is a limit. Actually, that limit is, pretty strict. Okay? Pretty strict. So things that are relatively complex, the DBMs cannot do. The DBMs usually not that smart to do relatively complex constraint enforcement. Okay, yeah, all right, yeah, we will see what kind of constraint the DBMs are not able to do. Okay, yeah. Here, let's look at the basic integrity constraints. All right. First, specifying a data type for each data item. That's very simple. Basic data type. Integer, float, double for numerical values, for string values, right? For date value, date values, and many other different values. Okay, yeah. So you need to specify. We, people, database designers, we need to specify that information. Yeah. So the DBMS can enforce. Yeah. Because this type of integrity constraint, very easy to enforce, right? Yeah. Because when you declare one data item should be an integer, but the user enter a string. Think about that. User enters string. It's not an integer. So the DBMS will reject it. Okay? The DBMS won't accept it because it's a simple to do. Yeah. Right. Yeah. Reject it. Okay. Yeah. All right. So this simple constraint can be enforced by DBMS easily. Okay. All right. The second type, referential integrity constraint. This one a little more complex. What's the referential integrity? Yeah. So this concept is related to another concept called a foreign key. Foreign key concept. All right. Yeah. So we will go there. We will learn the detail of the foreign key later. But here, I just give you a quick explanation for the foreign key. All right. So here, table 1, table 2. All right. Yeah. In table 1, we have rows, we have columns, right? Yeah. All right. So column, we also call the field. One field of table 1 refers to the primary key of table 2. Okay. That's the referential. That's the foreign key concept. Yeah. Yeah. For table 2, that's the key. Primary key, that's the key. Yeah. Primary key, later we will talk about that concept. Primary key. Yeah. Also very important concept. Because in a table, to identify each row, we need to use primary key. Okay. Primary key, the purpose, identify rows. Otherwise, how can you tell different rows? You just look at the primary key. of those rows, identify the rows. All right, that's the primary key. All right, but in our table 1, we need to refer some primary key in another table. This kind of reference, there is a relationship, right? This kind of relationship, this kind of reference. So we call in table 1, that is the foreign key in table 1. Okay, in table 1, we call it, oh, this is a foreign key. But this foreign key, we need to define it. The foreign key, we need to define it. We need to tell DBMS this is a foreign key. Otherwise, the DBMS does not know it. Okay, does not know it. Yeah. Yeah. So this constraint, there is a constraint, right? Yeah. You cannot violate this kind of relationship. So this constraint is also enforced by DBMS. Now, DBMS has to protect the integrity for this kind of relationship. Yeah. Okay, another basic type. Next, yeah, a record. Yeah, here I just, give you the general meaning. A record in one file. Table 1 here, one file. Remember, file means table. Yeah, last time. Yeah, in our database concept. Yeah. A record in one file, table 1, must be related to records in other tables, table 2, and here. I didn't talk about primary key, foreign key, right? Yeah, here, this is just general description. Yeah. All right. Another constraint called a uniqueness constraint. Uniqueness constraint. So what's that? Uniqueness constraint. All right. So let me explain this uniqueness constraint. In a table, we have many columns, right? Yeah. Here, let's look at one column here. All right. One column. Sometimes we need to sometimes we need to search against this column. All right, search against, okay. All right, so when we do that, unique values, this property is important. Unique value. Unique. Value. This property is important in our search against this value, this column. All right. So sometimes we may require the values for this particular column to be unique. That's the uniqueness constraint. So we declare the values for this particular column must be unique. So we set a uniqueness constraint on this column. That property could be useful, yeah, because later when we do the search, uniqueness property, when we do binary search, think about the binary search. Uniqueness property is very useful. Although if not uniqueness, binary search can also be done, but we may do things differently, right? Think about that. So if we allow duplicate values, when we apply binary search, we may need to consider the data value duplicates factor, right? Yeah. So that means uniqueness property will cause some difference in our search algorithms. Okay, yeah. For that reason, when necessary, we need to we need to add the uniqueness constraint for certain columns. Okay, all right. Yeah. This property also very simple. Yeah, and here the name key. If a column has the uniqueness property, we call that column a key. Okay, so here the key. So a column with unique values. Yeah, because this concept is important. So later we need to use key concept many times, frequently. One of our basic concepts, key concept. Okay, all right. And you can see this constraint, yeah, is enforced by D, B, M, S easily. Okay, yeah. For the fourth type, the last one, business rules, you know, usually it is complicated. Business rules, all business rules. Although some of the business rules could be simple, yeah, so we know some of the business rules could be simple, yeah. But for those relatively simple business rules, we can define some other constraints. Yeah. So the DBMS allows us to define relatively simple constraints, so they can, so the DBMS can enforce those constraints easily. Okay, yeah, but not for complex rules. Complex rules, we cannot use simple constraint definition to represent. Yeah. So for complex business rules, we may need to write our programs. We may need to write programs. Okay, yeah. So for the business rules, we know for this part, that's our responsibility, application programmers. Okay, yeah. Application programs. We need to write code. Okay, yeah. But the code is SQL code, right? Yeah. Yeah. So here, the core part, SQL code. Yeah. All right, SQL code, the core part to enforce. Definitely in our application programs, we may use our, high-level programming language. Check the business rules, right? Yeah, yeah. So here, mainly I like to focus on the SQL code enforcement. Yeah. SQL code. All right. Yeah. Okay. Yeah. So that's the, this concept, integrity constraints. Yeah. So we will see the details later. Here, I give you the general introduction. Okay. Yeah. So later, we will see the details for each type. We will see examples. So you will get better understanding later. Yeah. Here's still the abstract, high-level understanding. Okay. Now, the key topic for this part C, the key topic, store objects in database. Store objects. Okay. And this object, remember two different meanings based on the context. The meaning here, the object here, programming objects. not ordinary objects, programming objects. Okay. Yeah. Object-oriented, also, this object here, we refer to the programming object. Okay. Yeah. Object-oriented databases, programming object. Yeah. Let me explain this concept. How to store objects in database directly. Not indirectly, directly. Yeah. All right. Store programming objects directly into the database. Yeah. This is a new type of databases, completely different from our traditional databases. Okay. Yeah. Yeah. Or we can treat it as a special type of traditional databases. Special type. Yeah. Okay, traditional databases. Yeah. All right. Object-oriented databases. Okay. Yeah. All right. The main idea for this type, handling complex data structures. Yeah. We know in our programming, yeah, why we need to use programming objects in our programs. Yeah. Typically, we use programming objects to store structured data. Structured data. Okay? Yeah. Not the random data. The data has to follow certain structure. Okay? Yeah. First name, last name, many fields. All right? Yeah. And the structure could be very complicated. The arbitrary structure. Okay? Yeah. And when we use a class or an object to represent that structured data, it is very convenient for us programmers to manipulate our data. It's structured, so we can access, we can modify easily. Okay, the structured data. Okay, yeah. No object relation conversion. Now here, think about this. Think about this. Object relation. So what's the relation? Relation means table, right? As I mentioned before. Relation means table. Object. Now here, in order to store an object, programming object into a table, yeah. So here, think about the goal, people, those people, yeah, certain people, yeah, those people. So who are those people? Who are those people? Those people, yeah. Not us, not, we don't want to do that, right? We do not want to do that. But a group of people, they like to do that. So who are those people? Who are those people? Database researchers. Researchers, okay? Yeah. Some professors, researchers, right? Yeah. All right. So they are interested. They want to develop some new type of DBMS. They argue there are some good properties in this type of databases. Okay. All right. So no object relation conversion. This means they want to store programming objects into tables directly. Why? No conversion directly? Because conversion takes time, takes effort. Okay, so avoid conversion to save time and effort. That's their goal, all right? Yeah. And in this way, if you retrieve the data already programming object, so you can use your programming objects immediately. Okay, you do not need to do another round conversion. Yeah. Otherwise, before you can use your programming object, you need to do another round conversion. Okay, so they claim they can store programming objects, typically complex programming objects, into the database tables directly. So, and two-way conversions can be avoided. Okay, two-way conversions can be avoided. That's those researchers claim the advantage of this new type of DBMS. Okay, all right. Then the result, okay? This idea good or not, then the business world won't adopt it, won't buy the idea, okay? Nobody want to use this type of DBMS, so have not found widespread use. Okay, yeah, not widespread, actually, nothing, almost nothing. Okay, yeah. Think about the programming objects are binary data, right? The programming objects. How do you get a programming object? Programming objects. So here we need to, programming objects. Programming objects. Original form, binary data. So when you store the binary data in a table, we as users, can we recognize our data? We cannot. Yeah, because for the traditional data or for our textual data, yeah, typically we like textual data, right? So we can use our eyes to, go through everywhere in our database data. If we like to modify, so we can, change our data through some interface, okay, through some user's interface. Okay, so we have control on our data. That's important. That kind of control is important. Right? Yeah, but here, programming objects, if you like to modify a piece of data inside an object, how can you do that? Right? You lose the control. Okay, you rely on programs to modify. Okay, so that won't be convenient. That won't be convenient. Okay, yeah. So this type of DBM stay as research projects, after so many years, dozens of years, let's say dozens of years, still the business world won't accept it. Okay, yeah. But here, why I talk about that, right? The business world never accept this idea. Why I talk about that here? The following story from this idea, the following story, the business will accept it. The business will accept another version, not this version directly, another modified version. That becomes very popular in this business world. So I use this concept to introduce the next concept that is very popular in business world. So that's the reason. So here I use this idea as the background. Okay, before we can go to that popular DBMS, so I won't call DBMS. Actually, that one, we still use the traditional DBMS, but the idea is new. The idea is useful, new, and it becomes popular in the business world. Okay, so that's my goal. I like to talk about that. Okay, all right. Yeah, due to its complexity and not convenient to use, the business cost would be very high. So no reason to use this new research. So actually, you can from this example, you can realize many research projects cannot be used in the real world, in the business world. Many, okay, college professors, so they need a funding, so they, do research projects, get a funding from industry, from academia, right? Yeah. So they publish large number of research papers, describe their ideas. So very fancy, but probably only small portion of their ideas can be used in the business world. Small portion. Okay. Yeah. And this one never works. Okay. Yeah. But it's not a waste. It's not a waste. Okay. Yeah. Then the next idea derived from this one, that one is a success, is a huge success. So we will see that. Okay. All right. That idea is this one, this item called object relation mapping solution. Add this mapping word. Okay. Yeah. Mapping. That is, here we like to, here we like to do the conversion. Remember, those researchers, they want to avoid conversions. In their original idea, they want to avoid conversions. But an improvement is do not avoid conversions. Do not avoid conversions. That means we are willing to pay the effort of conversions. Okay. Yeah. So actually, people are willing to pay for the conversion. Why? Yeah. Because because they do not need to deal with the binary data. Yeah. Right? Yeah. Because if you avoid conversions, you have to deal with binary data directly. The original programming objects are binary data. Okay? Nobody wants to deal with binary data with their eyes, right? Yeah. Impossible. Okay? Yeah. But using our eyes to view the data directly, that kind of capability, we never want to lose that, right? Nobody wants to lose that capability, right? Yeah. So we are willing to pay extra effort to regain that capability. Okay. Yeah. So that's the reason we add a mapping effort. Mapping means effort, right? When you do mapping, it's not free. That means effort, extra effort. You need to pay. Okay. Yeah. So that model we call it ORM method solution. Yeah. Object relation mapping. And this idea is very popular in industry. Okay. Yeah. So I will elaborate. In my next slide, I will elaborate this idea because it's so useful, so important in industry. Yeah. So when you go to the industry, it's very likely you need to deal with, you need to use this technology in industry. Okay. Yeah. Yeah. All right. Object relation conversion is done by ORM tool automatically. Yeah. That mapping, we don't want to do manual way, right? Tedious work, although we can, but not productive. Okay. The manual way, not productive. And error prone. We are human, programmers, we're human, we can make mistakes easily. Yeah. You know. Yeah. So we want some automatic tool to help us to do that. Yeah. So that will be more efficient, more productive, and less error prone. Okay. Yeah. So I will give you the detail of this mapping thing. All right. Yeah. Okay. That ORM tool, the most popular one in industry here, I give you the Java case. No, it's called a Hibernate Java framework. It is an old tool. Okay. It has been used for more than 10 years. Quite popular, but it's an old tool. Okay. All right. And there are several similar tools. Yeah. Competitive, quite competitive against Hibernate. Yeah. So, yeah. A few others. Here I just, because the basic idea is similar. So here I just use this Hibernate as an example to explain this ORM idea. Okay. All right. The next slide. Let me explain this ORM solution in Java. Okay. Change the object relation mapping approach. Changed. I actually changed too, right? Yeah. Change from object-oriented to this object relation mapping approach. Okay. Yeah. All right. How to change? Yeah. Job. Yeah. No object relation conversion. Yeah. Job. Yeah. Yeah. Because this no object relation, this, if you look at the object-oriented OODB, object-oriented database, this is a main selling point, right? Yeah. What is the main selling point of object-oriented database system, management system? The biggest selling point is this one, no object relation conversion. But people won't buy it, okay? People won't buy it. So this selling point has to be drop it. Has to be drop it. In our ORM solution, we drop this big selling point, okay? Yeah. No sell, it's not a selling point anymore, okay? Yeah. Drop manual object relation conversion to, for that RDBMS, relational DBMS, okay? We do not want to do manual conversion, not productive, tedious work, no. Yeah. Nobody would like it, yeah. So we like to have some automatic conversion, okay, all right. Adopt automatic object relation conversion. Yeah. That would be great, yeah, automatic, yeah. All right, so now the implementation. Here, let me give you the implementation details. What kind of work we need to do in order to use this technology, ORM technology. What kind of work we need to do? Okay, all right. Yeah. Here, so let me use the Hibernate as an example. When we use Hibernate Java framework, yeah, we need to do the following things to set it up. We need to set it up, okay? Otherwise, it doesn't work. We need to do some work, okay? Setup work, mainly the setup work. Yeah. All right. How it works, yeah. Set up a configuration file. We need to use a configuration file to first get a connection, okay? Yeah. Get the basic connection, yeah. So those things. And then for the configuration files, certain basic information we need to specify in it, yeah. Like a database connection information. Database connection information. What's the database connection information we need? Okay, yeah. DB connection info. Okay, all right, yeah. URL, right? You need to specify the URL of your database. So URL, okay? Because you access your database through that URL, okay? Yeah, URL, right? Yeah, port number. The database running on a database server, so you need to use some port number. Okay, the port number, yeah. Username, password, right? Password. You need to have an account to access the DBMS. Okay, yeah, yeah, so that kind of basic information. Yeah, but actually a little more, yeah, like database drivers. Yeah. Database drivers in Java, you need to provide database drivers. Yeah. Okay, yeah. PHP, we do not need to. Yeah. PHP and Java, they use different ways. PHP, we do not need to use database drivers, but Java, we need to use database drivers. Okay, yeah, all right. Yeah. And location of mapping files. How to do the mapping? You need to tell the framework, Hibernate framework, how to do the mapping. So you need to use a set of mapping files. Okay, all right, yeah. And for the mapping files, yeah, what the format? So they're in XML files. The mapping files are in XML files. And you know, another property files less popular. Yeah, XML, the popular one. Yeah. More popular. Okay, XML files. All right. In the mapping files, we need to do this. One mapping file for one table. One mapping file serves for one object. One object corresponds to one table. So you do, you know, one-to-one correspondence. Okay, yeah. Do the mapping in the mapping files. All right. And the definition of mapping objects. Mapping objects, that's the programming objects. Yeah. You need to create a definition of mapping objects. Basically, they are Java beans. Basically, they're standard Java beans. Okay, Java beans. Yeah, that concept. All right. Yeah. All the supporting files are generated automatically. So after you set it up above items. Okay, get ready. All right, click button, generate. Yeah, because you know, yeah, those, yeah, actually the Java beans can be generated automatically. You do not need to type manually by yourself. So you just click the button, the Hibernate tool. Okay, Hibernate tool will generate automatically. Yeah, think about if you have hundreds of tables, do you want to write hundreds of Java beans manually, right? You know, not, at least not productive, right? You need to spend many days to do that tedious work. But if you click the button, 5 seconds, you get everything and no typo, all right? You know, everything is perfect. Yeah. Think about you work the whole week to write the Java beans of hundreds of Java beans. How many typos do you have? Right? You know, yeah. If I have a chance, I will show you, you know, this procedure. Click button. All right. All right, that's it. I run out of time and we finish this topic. The good thing is